Let's see here. The global average temperature is, I can't read that thermometer. I can't even read the scale. Is that Celsius or Fahrenheit? Oh, of course not. Of course, this is not how this works. You do not read global average temperature from a thermometer, and that should be obvious if you actually stop to think about the concept of global average temperature. What does it mean, and how does one go about measuring it? Well, if we're talking about an average temperature for the entire planet, we cannot be talking about the temperature that's measured from a single thermometer. So how do you go about measuring an average global temperature? Well, perhaps it might occur to you to do this. Okay, now we've got a bunch of different thermometers, and we'll just combine all of those readings and average them out, right? Well, that doesn't work out so well either, for reasons that again become apparent when you start to put the scope of this idea into proper context. Let's use an analogy here. Let's imagine you're going to try to measure the average length of blades of grass in your lawn. How do you go about doing that? Well, I guess you could take some representative blades of grass, maybe 10 blades of grass or so, and average the length there and say that that's the average length or a good approximation thereof. But, well, does 10 blades of grass really give an accurate representation of the average length of your lawn? And in fact, this, although obviously this is a problem, and it is a problem when we go about calculating average temperature from a weather station record that is, well, if you look at the surface air temperature station record, there are huge gaps in this. In fact, we'll quantify it later, but 70% of the land surface on the planet is unaccounted for by these weather stations. So from 30%, mostly concentrated in Europe, some pretty good coverage in North America and parts of South America, and Asia's getting there. Vast swaths of Siberia and northern Russia unaccounted for, Central Asia largely unaccounted for, most of Africa unaccounted for, large parts of Australia unaccounted for, pretty much the entirety of Antarctica unaccounted for. Some pretty large gaps in the weather record there, equivalent to, well, maybe not 10 blades of grass, but how many blades of grass do you need to form an accurate global average temperature? And unfortunately, it's even more complicated than this, because at least in this example, in this analogy, well, you're only really dealing with the two dimensions. I mean, the difference in height of blades of grass is not going to, for example, it's not going to differ between the time that you take and collect the measurements and average them out. There's not going to be a significant difference in the length of the blades of grass themselves. But of course, the temperature of the Earth in any given location is changing throughout the day at all times. And that's even, again, just thinking in two dimensions. Well, how about three dimensions? Because of course, when we're talking about the Earth temperature, what temperature at what height are you talking about? We have the troposphere, the stratosphere, the mesosphere, the thermosphere. And temperatures are different at all levels of the atmosphere, going down, of course, as you go up through the troposphere, going back up in the mesosphere, dropping down as you approach the thermosphere, and then in the thermosphere, it's rockets back up. In fact, in the thermosphere itself, you have the absorption of solar radiation directly into gases in the thermosphere that make it the gases themselves at 2,000 degrees Celsius. But if you had a thermometer in the thermosphere, it would register below zero because there wouldn't be enough actual transference of that kinetic energy from the gases to actually excite the thermometer and the air around the thermometer and transfer any heat in that fashion. So it kind of brings up the question of even what temperature is and how we measure it and what that's actually reflecting. But that's maybe a bit of a more philosophical question. But still, the point is taken that throughout the atmosphere, you have different layers and you have different temperatures at different layers. So what are we talking about? Well, obviously, since we're human beings and we're concerned primarily with human beings and what's happening to us and the wildlife around us, let's take a look at the 75% or so of the atmosphere by volume that's in the troposphere, that first 11 to 13 kilometers of the atmosphere. And it's down here that all the relevant weather patterns form. This is really the place where we're looking at, or we're concerned about primarily. And people from previous video might remember the troposphere is where we would expect to see the fingerprint of global warming, the hot spot where we would expect to see the warming being trapped, and of course the greenhouse gases collecting in the above the troposphere, in the stratosphere. But again, even if you're just looking at that 11 to 13 kilometers next to the surface of the Earth, that thin slice of air that really keeps us alive here on this blue marble, well, what are we talking about with that 11 to 13 kilometers? So where exactly are we measuring the surface air temperature? If you think I'm being facetious about this, I'm not. One of the keepers of one of the standard data temperature records for surface air temperature, Goddard Institute for Space Studies, has this handy dandy fact where they talk about the elusive absolute surface air temperature. And under what exactly do we mean by surface air temperature? They themselves say, I doubt that there is a general agreement about how to answer this question. Even at the same location, the temperature near the ground may be very different from the temperature 5 feet above the ground, and different again from 10 feet or 50 feet above the ground, particularly in the presence of vegetation, say in a rainforest. The temperature above the vegetation may be very different from the temperature below the top of the vegetation. A reasonable suggestion might be to use the average temperature of the first 50 feet of air either above ground or above the top of the vegetation. To measure surface air temperature, we have to agree on what it is, and as far as I know, no such standard has been suggested or generally adopted. Even if the 50-foot standard was adopted, I can't imagine that a weather station would build a 50-foot stack of thermometers to be able to find the true surface air temperature at its location. So again, even the people who keep the surface air temperature record are admitting that it has to be an artificial construction in some way. And well, do you think that they can just take raw temperature data from thermometers and put it in? Well, what thermometers located where, in what way, and how do you weight them given the gaps in the station records and things of this nature? It is a lot more complicated than you might think at first glance. And in fact, it's even more complicated when you start getting into the actual ways that they do try to calculate a global average temperature. Something that, well, as Canadians might know, of course, this is David Suzuki, broadcaster and emeritus professor, who is hailed by most Canadians as a wonderful genius of science and a proselytizer for science, and someone who, of course, believes wholeheartedly 100% in catastrophic anthropogenic global warming. And he was surprised by a question on the Australian Q&A program a couple of years ago.
So where are you getting your information? I'm not a climatologist. I wait for the climatologist to tell us what they're thinking.
Well, you want to respond to that, Bill?
Sure, yeah. UAH, RSS, HADCRUT, GISS data shows a 17-year flat trend, which suggests there may be something wrong with the CO2 warming theory.
Yeah. What is the reference? I don't...
Well, they're the main data sets that IPCC use. UAH, University of Alabama, Huntsville, GISS, Goddard Institute of Space Science, HADCRUT, I don't know what that stands for, HADCRUT, and RSS, Remote Sensing Something. So those data sets suggest a 17-year flat trend, which suggests there may be a problem with the CO2.
There may be a climate skeptic down in Huntsville, Alabama, who has taken the data and come to that conclusion. I say let's wait for the IPCC report to come out and see what the vast bulk of scientists who've been involved in gathering this information will tell us. I'm not, we can cherry pick all kinds of stuff. Cherry pick, in fact, the scientists that we want to listen to. But let's listen to the IPCC.
Indeed, the ignorance on display here is quite phenomenal. And look, I don't mind at all for most people on the planet not to have any clue what UAH or GISS or RSS or any of these ridiculous acronyms are, what they mean, let alone how they're calculated or what implications they have for things like global average temperature calculations. But for someone who literally believes that people who ignore climate science should be put in jail, the level of ignorance on display here is quite phenomenal. So, let's roll up our sleeves and hopefully roll back some of that ridiculous amount of ignorance. And I'll direct you to an excellent website, climateforyou.com, that has extensive data and information on all sorts of different things to do with climate, air temperatures, global temperature, oceans, polar temperature, polar precipitation. Lots and lots and lots of data presented in a very, very neutral way for people who believe in global warming or disbelieve in it. This is just reams of data, and also context for what that data is, where it comes from, how it's interpreted. An excellent website that I suggest that you check out if you're interested in these things. Under global temperature, they talk about the different data sets that exist, and they say all temperature diagrams shown below have 1979 as starting year. This roughly marks the beginning of the recent period of global warming. In addition, the year 1979 also represents the starting date for the satellite-based global temperature estimates, UAH and RSS. For the three surface air temperature estimates shown, HADCRIT, NCDC, and GISS, the reference period differs. HADCRIT refers to the official normal WMO period 1961 to 1990, while NCDC and GISS as a reference instead use 1901 to 2000 and 1951 to 1980, respectively, which results in higher positive temperature anomalies. Okay, again, there's a lot of stuff to go through here. For example, the fact that, as we say, it's very, very difficult to come up with a global average temperature, a number that somehow reflects the average temperature of the planet. So when in these types of temperature charts, you will always see them presented as temperature anomalies, i.e. the difference between the current temperature and a given period, 1901 to 2000 or 1951 to 1980. So they're trying to look for temperature anomalies more so than they are an actual global average temperature. And these are the types of records that they're looking at: UAH, RSS, HADCRIT, NCDC, and GISS. UAH and RSS are satellite temperature records. HADCRIT, NCDC, and GISS are surface air temperature estimates. This is important because there are different quality levels of different temperature data sets. Quality Class 1, the satellite records, UAH and RSS, are Quality Class 1 because satellite temperatures are generally more reliable than surface air temperature estimates. They are more. They have a higher sampling rate. Usually, satellite records will sample the entire surface of the Earth twice a day, or something on that order. So they're very extensive, very reliable temperature records. Whereas HADCRIT, NCDC, and GISS are surface temperature records that are less reliable. For example, Quality Class 2 is the HADCRIT surface record. Quality Class 3 is NCDC and GISS, because NCDC and GISS often experience quite large administrative changes, a concept we'll come back to later, and therefore essentially must be considered unstable records. Changes are introduced to HADCRIT, but they're fewer and smaller. And then there's talking about the sea surface temperature record that factors into this. So again, a lot of stuff to go through, but the upshot of this is that when you compare the satellite record, the Quality Class 1, to the HADCRIT and the GISS and NCDC, the Quality Class 2 and 3, the surface air temperature estimates, you find that there is an appreciable difference in temperature anomalies. In this period, 1979 to 2008, the satellite record found a temperature anomaly of 0.45 or 0.37 degrees Celsius, whereas the less reliable HADCRIT found a 0.55 degrees Celsius temperature anomaly, and GISS and NCDC found 0.64 and 0.58 degrees Celsius temperature anomaly, respectively. That means, essentially, that the satellite record is diverging from the surface air temperature estimate record, and the satellite record is showing less warming than the less reliable surface air temperature record. Again, this is something that has been confirmed in various ways. I'll throw this post. RSS continues to diverge from GISS, that was released just yesterday, talking again about this divergence that is taking place and is demonstrable between the more reliable satellite record and the less reliable surface air temperature estimates. And the most revealing part of this is probably this, showing the trend from 1979 to 2015, which shows that between 1979 and 2001, although the actual numbers of this anomaly were different between the satellite record in red and the surface air temperature estimate record in green, the GISS temp, the trend was roughly the same, which shows that there's at least something that seems to be converging here, and it looks like that the data is in some way going together. But from 2001 on, suddenly the surface air temperature estimate record continues to rise, but the satellite record is showing actually a slight degree of cooling. And this, of course, is the pause which everyone has probably heard of by this point, the pause in global warming, which, for people who don't know, I'll do an entire video on this alone so you can find out more about it. But number one, the start point of the pause is not arbitrary, it is calculated. And number two, it is calculated from the RSS, the satellite global mean temperature change. It's a least squares linear regression trend on the RSS satellite monthly global mean surface temperature anomaly dataset. And it shows that now, as of December, 18 years and 9 months of no global warming. So again, the satellite record and the surface air temperature record continue to diverge, and the satellite record, the more reliable record, shows that there is no significant warming taking place. No statistically significant warming has taken place for almost 2 decades. Now, again, just to back up, why is this? Why is the surface air temperature record less reliable than satellites? It goes back to that weather gap, the weather station gap that we looked at earlier, and again from Goddard Institute for Space Science in their FAQ on the GISS surface temperature analysis. They have this question, what is LOTI, the Land Ocean Temperature Index? And it says, weather stations reporting surface air temperatures are positioned on land, which covers only 1/3 of the planet. The rest is covered by oceans, where SAT reports are rare. So not only do you only have about 30 to 40% of the land covered with weather stations, only 30% of the planet itself is covered in land. So again, it's a fraction of a fraction that is making up the temperature record that they're using. And just to put this into perspective, this is the percentage of US-based data records, temperature data records, that goes into the GHCN, the Global Historical Climatology Network temperature data set. So it varies depending how far back in the record you go, but upwards of 50, 52, 53% in the early 1900s, again, breaching over the 50% record in the 1990s and 2000s. Still, about 40% of the entire GHCN global surface air temperature estimate comes from US-based records alone, and the US land surface is 6.6% of the entire Earth's surface. So 6.6% of the Earth's surface is making up more than 40% of the data that goes into this global average temperature number for GHCN. So again, it shows you why things are not quite as reliable as just averaging a bunch of thermometers together. But how about, why can't we just use the raw data? I mean, we have raw data from all these weather stations. Why do we need to calculate anything? Why don't we just add them together and average them out? Just averaging the raw data would give results that are highly dependent on the particular location's latitude and elevation and reporting periods of the actual weather stations. Such results would mostly reflect those accidental circumstances rather than yield meaningful information about our climate. Can you illustrate the above with a simple example? Assume that a station at the bottom of a mountain sent in reports continuously starting in 1880, and assume that a station was built near the top of that mountain and started reporting in 1900. Since those new temperatures are much lower than the temperature from the station in the valley, averaging the two temperature series would create a substantial temperature drop starting in 1900. Well, how can we combine the data of those two stations above in a meaningful way? What may be done before combining those data is to increase the new data or lower the old ones until the two series seem consistent. How much we have to adjust these data may be estimated by comparing the time period with reports from both stations. After the offset, the averages over the common period should be equal. This is the basis for the GISS method. So again, they go on and talk about different methods for this homogenization of data from different stations, or to smooth out areas where there's a little coverage, or where there's adjustments needed in order to make things, smooth out with the data. And this is really the core of why the surface air temperature estimates are not reliable data sets. And there's more on that from this Climate for You website on temporal stability of global air temperature estimates, where they go through and break it down by the different types of temperature records, satellite, and what have you. They show the different temperature records and how they've been altered over the years, the adjustments that have been made to them. It's a lot to go through, but I'll provide this link as just a short form version of this, data tampering at USHCN GISS, and it shows how the measured USHCN daily temperature data shows a decline in US temperatures since the 1930s, but before they release it to the public, they put it through a series of adjustments which change it from a cooling trend to a warming trend. So before it goes downwards, there's a downward trend, And then they take that data and they do their magic, and look, it's warming. It's warming, I tell you. And that's not just one or two isolated examples. There are many, 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 many examples of this where they take the high temperatures in the past and they make them lower. And they take the lower temperatures near the present and they make them higher. Nothing has changed in the actual whatever did happen in the 1930s. They're just changing their records so it makes it look cooler in the past and look warmer in the present to give a more pronounced warming trend that is in line with this catastrophic anthropogenic global warming hypothesis. Again, you can take a look at the changes that were made to GISS U.S. temperature data since 1999 in GISS version 3, and look at that. Lower in the past, higher in the present. Again, this is how much they're adjusting the data. So, of course, you've got to adjust the past lower. And again, it happens in Reykjavik. It happens in Alice Springs. It happens all over the world. They're adjusting the temperature. And again, it's pretty obvious when you take a look, and this is the changes reported in GISS since 1999. Just look at that, where they've lowered the past and warmed the present. It's a nice way to create warming, anyway. And so that's what's been going on with the adjustments. So again, the question of how we actually get a global average temperature is unfortunately not as simple as sticking a thermometer out and just measuring a temperature. It is a calculation. There's a lot that goes into it. And we have covered a lot of the different shenanigans that go into this, but really, this is only scraping the surface. What we've covered so far is only the background that you would need to have in order to even begin parsing through the debates about the temperature record and how reliable it is or is not. But let's just keep in mind what we looked at in a previous video here. Refereed papers, uncertainty in the global average surface air temperature index, a representative lower limit, which concludes a representative lower limit uncertainty of plus minus 0.46 degrees Celsius was found for any global annual surface air temperature anomaly. This plus or minus 0.46 degrees Celsius reveals that the global surface air temperature anomaly trend from 1880 through 2000 is statistically indistinguishable from 0 degrees Celsius and represents a lower limit of calibration uncertainty for climate models and for any prospective physically justifiable proxy reconstruction of paleo temperature. The rate and magnitude of 20th century warming are thus unknowable, and suggestions of an unprecedented trend in 20th century global air temperature are unsustainable. Again, so pretty important conclusions, but one that you won't see trumpeted in the mainstream media in the same way that you'll see all of those hottest year ever claims. Hottest month ever is reported like clockwork every year. And, we'll break down in another video just how much bunk goes into those claims. But, again, statistically indistinguishable from 0, the rate and magnitude of 20th century warming unknowable, and suggestions of an unprecedented trend in 20th century global air temperature are unsustainable. Well, I bet you didn't think you'd get through all of that information, and all of this will be in the show notes. All of this data will be in the show notes for you to go and peruse for yourself. But that's an awful lot of information for a very seemingly simple question. But hey, look on the bright side. If you made it through this video, then you now know more about the global data, temperature data and how it's constructed than David Suzuki. Not that that's saying much. James Corbett, CorbettReport.com.